right, so in the video today, we're going to go over the choke, the electric choke on the EMPI Pict 3 carburetor. I've had this in my 79 Super Beetle now for a couple of weeks, and it has suffered a problem with a sticky choke. And initially, I was thinking maybe there's some gum in there. I don't know, maybe there was some problem with the linkage, but I just could not get it to free up. And you go out in the car and it's cold and you're expecting the choke to close and it doesn't. And so you have to open it up and just help it a little bit. That's not how an automatic choke is supposed to work, right? So today I decided I'm going to rip it apart and I'm going to find out what's wrong with it. There's a couple of things here that you need to take into account when you start to disassemble a carburetor, in that a lot of the screws with the choke in particular, they have, so a lot of these screws, they'll have Loctite on them so that they don't fall off and go down into the engine. And so you have to be very deliberate in the way that you take these screws off. Initially, I started doing my diagnostics with the carburetor in the car. And then when I got to the point where I needed to take off the choke flap here, so that I could inspect the shaft, I realized, I'm going to have to take off either take the entire carburetor out or at least take off the top. So that's what I ended up doing was I took off the top half of the EMPI Pict 3 carburetor. You can see you can lay it flat on a surface, but you have to protect. This right here is where the float valve is. This is what controls the flow of fuel from the fuel line into the float bowl. But this whole top half of the carburetor can come right off with just 5 screws. Now, normally I would do a video about a topic like this, and I'll plan it out, and then I'll go over the disassembly and then the reassembly of the item. But in this case, I didn't know what the solution was. I needed to get to the bottom of it, and I didn't want to do a video of me just fumbling around until I solved the problem. But now I've solved the problem. And in this case, the reason why the choke was sticking, either open or closed, it didn't matter which position it was in, was because of a combination of assembly defect and a manufacturing defect. So this right here is the shaft for the choke. When you put the choke in place, a little butterfly goes in and then it opens and closes the choke, right? That's how that works. But the way that they make these, you can see when you're looking at the groove here, they start with a shaft and then they take and they cut a hole or a slice in the middle of the shaft so that you can slide the butterfly valve in there. And so when you're looking at this side, the hole is this big, right? But when you look at the other side, the hole is much bigger because they don't take a square tool, they take a round tool and they just cut a slice, right? So with a round tool rotating, they insert that and they cut the slice, and it doesn't go all the way through. So the holes are different sizes on this side and on that side. And what it turned out the problem was part of it was the design. Because they cut that slice and they made a bigger hole, what it did was it gave an opportunity, I don't know if you can see right here, for a burr to develop right in this little area. This goes inside. This part on the outside is where the butterfly valve is, but from here to there is inside the bearing. And what had happened, and you can see there's a little bit of wear right here. A little bit of a burr got caught in there, and when they assembled it, it just got stuck in. They assembled it and moved on down the manufacturing line. Nobody checked to see if a burr was in there or that this thing was freewheeling, that it was sticking. And if they had just taken it apart before they put all these parts together with the Loctite and made it permanent, I mean, if you're looking at the end down here, these threads, I'm hoping this is going to go back together right. Part of that is wear from the linkage, but there's still plenty of good threads on the end here. But I just really hope that it all goes back together well. But what had happened is that right in this little area right here, a little piece of aluminum got caught up in that because in the manufacturing design, it was wider, and this went into the bearing, and it caught some aluminum. And the first time you use it, it just would jam itself in there. So all I did is take it apart, clean it out, put it back in. Now, when you put it in here, it's freewheeling. There's no problem. There's no stick. So it doesn't have an issue. But what it was doing was right in one little area. Here you can see there's the burr right on that edge. It was getting caught right there, and it was either getting stuck open or stuck shut, and it was making it so that the electric heater that opens and closes this choke didn't have the horsepower to turn past that little burr. But now that I got it all cleaned up, I'm going to go over the reassembly, and we'll make sure that everything works fine. See, there is the little piece of aluminum right there where it got stuck. If I can get him really close, there's a little burr right there, and it got stuck. So I'm going to make sure that that's not going to be a problem in the future, and we'll get it all back together. So normally, like I said, I'll go through these videos and I'll cover how to disassemble something. In this case, I'm going to do it in reverse. So I'm going to go over how to reassemble it after it's been taken apart. So let's go ahead and get started on it. This was a EMPI Pict 3 out of in my case, a 79 Super Beetle. It was a fuel injection to carburetor conversion kit from J-Bugs. Great products, great line of products that they sell over there at J-Bugs. In this case, just missed the mark on the assembly or the manufacturer, whatever it was, a shortcut that caused a problem and required me to disassemble it and then reassemble it. All right, let's go ahead and get started in putting this thing back together. All right, so first things first, we got the shaft back in here, and we're going to place the butterfly. If you're looking at the geometry here, the butterfly is got a flat spot on one end and a round spot on the other end. And if you're looking at the shaft, you'll notice that there are countersunk holes on one side and just straight through holes on the other side. These other side holes are threaded, and the ones on this side are not. So the screw heads are going to go into the countersunk side, and they're going to receive the threads on the other side. So you want to orient this shaft so that you can receive the butterfly in the right position, right? So on the bottom part down here, you can see there's a flat spot right here. That flat spot corresponds with this flat spot right here, all right? So the other thing is that when you're looking at the butterfly, I mean, you could go through the effort and round this off, I guess, with the sandpaper, but what you'll notice, this is a stamped piece of metal, and there's a rounded side and there's a kind of a roughed edge. You want that rounded side to be up because the airflow is going to be coming from the down, and you don't want to create any more additional turbulence, right? So we want the rounded side of the butterfly to be up. So what you're going to end up doing is pushing in the round side till the holes meet up, and then you push it right up here so the square is up. You got the round side of the punched out butterfly on the top, and you just throw those screws in there. Now, the typical installation when you're putting these screws in is to throw a little Loctite in there. I prefer, in this case, to get them slightly threaded in place and then come back and throw some Loctite in the back of the threads from the back side and then tighten them in. When you tighten them that way, then you won't have Loctite getting all over the place and it won't be a big mess. All right, let's throw these babies in there. All right, so we're going to use the Loctite red. Red is the permanent stuff. Just a little touch. You don't need this stuff all over the place. It doesn't need to make a mess. So you can see I've got these partially threaded. Whoops. Partially threaded in here. I'm just going to put a little touch. Boop, just like that. Here you can see, got my Loctite in there. Maybe too much. I don't want to make a big mess. Anyway, it's just enough to get it on the threads. I'm going to go ahead and tighten these in. All right, nice and snug. Okay, we're going to do what they didn't do in the factory, and we're going to test to make sure. Yes, we have good free range of motion here. It's no more sticky clutch. That thing is moving on its own. That's what we're looking for. Nice and free range of movement. All right. So the next thing we're going to do here is, you'll notice there's a little hub right here. That will connect with a little vacuum pump that connects right in here. So we're going to put that in next. Let's go ahead and grab that thing. All right, so this little pump, you can see it has a little slide area right here. That goes underneath that right there. So we're going to slide this thing like this and get that just like that. Now the other thing you need to do is make sure that, you gotta line up the holes here, right? There's a hole on the little rubber that goes to this vacuum hole right here. That's what's going to activate this when, and it will open and close the choke when you have enough vacuum. All right. So you can see we have this in here, and it will be able to move like that to move the clutch when it needs, or the choke when it needs to. That's how that works. We got that hole lined up right there. Gonna throw the gasket on there. Again, lining up that hole. All right. Oops. All right, here's the hole on this side. That had passed through all those, the hole passes through and it gets to the back side here where it will be able to apply the vacuum that it needs. All right, everything lined up. Going to a standard flat screw. Okay, now we have the choke all lined up with the vacuum assist doing what it needs to do. All right, next thing we need to put this electric solenoid on the outside here. It's actually not a solenoid, it's It's a heat element, and that will engage this little tab right here. Let's grab that thing. All right, so this is the electronic component, if you want to call it that. It's actually it's a heating element. But the first thing is you need to put this little spacer in here. So you slide that on just like that. It kind of has a place where it wants to be. Just need to make sure it has free range of motion. And then this little tab right here, you can see like a little handle. You want that to grab onto the little hooky dealy there. You can see that it's got a hold of it, right? That's kind of where you need that to be. All right, so this is adjustable by moving it, right? And the way that you adjust that is with this little disc right here. Normally this disc would be, kind of installed right here. You have a couple of screws, and then when you put them on loose, then you can still move this because this disc doesn't grab onto it until you tighten it down. These screws are a little tricky because they have a spacer that goes in between, so you kind of have to do it in pieces. All right, so there we go. So that'll be the first one. A couple of screws. All right, so let's get the second one in here. Still have that in the right place. I'm going to put a spacer in there. Grab it with a screw. Just give it a couple of twists so that you can get the last one in. All right, so with all three of the screws kind of lightly tightened in there, we just kind of have them in place. We want to set the 0 point, right? So if you're looking at the choke, you can see that if you turn this, it'll close, right? See how I'm turning right here? We don't want to make it tight, too tight. We don't want to make a spring out of it, but we want it to close enough so that when that coil starts to uncoil, because right now it's cold, I mean, I'm physically holding it in my hand. I mean, how cold could it get? This is going to be 0. We're going to call that 0 right there. All right, let's go ahead and tighten these up. Okay, again, that's loosely tightened, but it's snug. It's not moving anywhere. It doesn't spin anymore. And then once we get it in place, then we'll tighten it up for permanent, and everything will be happy. Now, I like the way that this moves now. This is just exactly what it's supposed to be doing. All right, so let's go ahead and put the linkage together. Actually, I can probably do this right here. All right, so this little piece right here is got a little flange on it, and what that does is it moves this cam. This is the throttle cam that is the choke advance. So basically, when the choke is on, it'll grab onto different parts and it'll keep the throttle open. And what this little thing does is it grabs this back piece like that. See that? And so when the choke is engaged, it pulls it down, and when the choke is open, it lets more throttle out, so it can idle slower. All right? So this little washer goes on here, a little split washer, and then a little tiny nut we'll go on there. All right, again, we're going to deal with, I think that we're going to tighten this on as best that we can because these threads are slightly damaged. There we go, that's nice. So again, they had permanent Loctite on there, so we're gonna have to put something in there to keep it so that it doesn't come off. So again, we're gonna throw a little bit of Loctite in those threads, and try to keep the Loctite from getting down in here for these moving parts, just on the threads right here. So that way it won't back off. It doesn't need to be tight. It just needs to be, you know, secure so that these things can move freely. That's exactly the performance that I was missing before. It was always stuck. So this would be good. All right. All right, here we are with the top mated with the bottom. You can see there's 5 screws, 1 in the front and 4 on the bowl. 1, 2, 3, 4. So we're going to go ahead and tighten those up and then put the fuel line back in place, put our air cleaner back on, and then we'll give it a go. Let's see how it goes. All right, there we go, all reassembled. I think I went through everything pretty accurately. This was a little spring you got to add onto the little arm here, but you can see I've got the little cam doing what it's supposed to be doing, and the choke is freewheeling. That is not sticky anymore. That won't be a problem at all. Here we've got the idle solenoid sharing electrical power with the ignition circuit. So when the ignition is on, everything should be golden. Let's go ahead and fire this thing up and see what it does. That seems to be running pretty well. I'd call this a success. Here you can see where the throttle, after the engine's warmed up, when the throttle has come down off of the cam and the choke is back open, the throttle doesn't sit on this anymore. It's just barely touching. So anyway, that shows that this is nice and free moving and there's no problems with the choke anymore. Alright, so just a real quick summary. We had a sticky choke. After running it for a little while, the car was difficult to start, and we always had to move this little device right here to get it to free up. So I ended up having to take the whole thing apart and found a manufacturing or an assembly defect from the factory with a little burr on that shaft. Cleaned up the burr, put it all back together, everything's running fine. There you go, this is the EMPI Pict 3. Make sure that if you like these videos, you can subscribe. Check out my site, I got a lot of stuff here on the VW, and I got some stuff on the MGB and a couple other things. So that's all I have for today. Cheers!